Hello and welcome to Lab 2 Lines of Charge by Isaiah Tanon. Introduction to this lab is very similar to the first lab, where we're generating a hands-on understanding of how neutral matter can gain charge after friction with other neutral matter using Scotch tape. However, this time we are calculating using a line of charge made up of infinitely small DQs instead of treating the whole tape as a point charge. Some fundamental principles we need to know is Coulomb's law, Newton's second law. Neutral objects can gain charge through friction, and largely charged objects are made up of infinitesimally small charges known as dq, and these charges together produce a net electric field and force on other charged objects. We also need to understand superposition, and more specifically symmetry. An experimental overview is it's largely based off of Lab 1, where we still have the two tapes that are ripped off of each other, gain charge, and repel each other after being set up vertically. Last time we figured out the tapes were positively charged, and this time we're creating a computational model using a line of charge instead of a point charge, and we are demonstrating how each of these infinitely small charge contributions make up the net field. Some design from the last experiment, just seeing tape B, the system that we're working with, set up above tape A, and we're seeing its displacement, and on the right we see two tapes separated by a distance d. And here's a preview of my end model, where we have the green arrows representing each infinitely small charge from the bottom tape onto the top tape, the white arrow representing the net electric field from the bottom tape to the top tape, and the yellow arrow representing gravitational force. As we can see, the magnitude of electric force and the magnitude of gravitational force are virtually the same. Some basic measurements for the tape. The tape is 20 centimeters long, 1.5 centimeters wide, 0.2 grams heavy, and the displacement between the two tapes and the distance between them is 2.5 centimeters. G, of course, is negative 9.81 meters per second squared, and K is 9e to the ninth. Some of my calculations, I decided to calculate Q on my own and also do it according to the computational model to see any error. The force of gravity ended up being negative 1.96 e to the negative 3 newtons, so the electric force has to be the same but in reverse. And the Q of each tape, according to my calculation, was 2.37 e to the negative 8th coulombs, and the Q according to the model was 2.516 e to the negative 8th coulombs. So within the same magnitude, just off by a little bit. This is probably due to some rounding error or just any discrepancy between our calculations. The coding for this project, we can see where I code for the electric field, where the line of charge is coded, where the objects are actually created using the line of charge code, all the scales for everything, and how the DQs of the bottom tape are calculated onto the top tape. And again, how the net electric field and the net electric gravity are calculated. Here again is the model. Again, the green is the DQ field, the white is the net field, and the yellow is the net gravitational field. And again, the forces are virtually the same. Some key assumptions that we made is we ignored air resistance on a moving object. Since the top tape is moving when the bottom tape repels it upwards, we're only considering gravity and electric force. We're not counting any air resistance that could be keeping the tape up or preventing it from going up as high as it can. We are not treating each tape as a point charge. We did that in the last lab. However, this time, again, we're using a line of charge made up of small DQ point charges. We are, in fact, assuming that each U-tape is made of the same amount of charge and it's evenly distributed. We are not counting for any differences in the charge or if one side of the tape has more charge than the other. Again, we're focused on that symmetry, which is why the net electric field only goes one direction and doesn't have any Z or X component to it. We're also assuming there's no DQ interactions. It's only interacting with the top tape. Additional questions, point versus a line charge, we're also known as comparing it to Lab 1. Lab 1, we got a value of 1.17 e to the negative 8th coulombs, and this one we got 2.57 e to the negative 8th. This 2.57 is going to be more accurate since the tape is not truly a point charge. Treating it like a point charge was just for convenience. But treating it as a line charge is more true to how it actually exists, since point charges don't really exist in nature outside of an electron, per se. And treating it as a sum of small points is more accurate to a calculation. However, both of these Both of these calculations assume even charge distribution, which isn't necessarily true. However, it's going to create much less error in a line charge than a point charge. And the more DQs you use in a calculation, the more accurate your result will be. That's the end.